So this session is a quick session about safety. Like, the first thing you have to know is, of course, to follow all the rules of the workshop you are working in. Some workshops have rules of you have to have goggles all the time. Some workshops have rules you have to have steel-toed shoes all the time. So whatever the rules are of the place you work, obviously you follow them. But the purpose of this short video is actually to point out to unexpected safety hazards, because I'm assuming you know the basic safety hazards of all the machines, but there's quite a lot of unexpected safety hazards. So surprisingly, the most dangerous machine in a machine shop is always a woodworking machine. Now, the reason for that is that woodworking machinery runs at very high speed and the tools are very sharp. Typically, woodworking tools run at 10 times the speed of metalworking tools, the surface speed, and all the tools are very, very sharp. So the chances of cutting off your finger in a woodworking machine is much, much higher than in any metalworking machine, because it only takes a fraction of a second. If this would simulate your finger, okay, all what it takes to cut it off, and even if you think the blade, is almost stopped, if you carelessly bring your hand to the blade just before stopping, it can still cut off your finger, even at that speed. And you can see that when I turn it on, let it almost stop, it will still cut off your finger twice, just with the last few turns the blade makes. Okay, so it's a very, very dangerous machine, even when it's nearly stopped. So obviously you stay away from the blade at all times. If you have to cut the end of a piece of wood, your hand is far enough from the blade, so you have no problem. But if you have to cut the wood lengthwise, if you get any closer to the blade, you have to use a piece of wood or a tool like this to push the wood. You cannot use your hand. And the other important thing is, of course, if you have small pieces, you always have to use a piece of wood to push it. The most important thing is never be tempted to stand behind the blade. Let's say if you cut and it's a long piece and you're tempted to pull it from the other side. So if this made some cut, and never stand behind it and try to pull it, because the blade, if anything gets stuck, the blade will pull the wood and your hand in this direction into the blade. So you never stand behind the blade in a table saw, and you always work from this side, and you always keep your hands very far from the blade using some kind of tool, even if the blade appears nearly stopped. So that's about it. There's no special unexpected safety things. It's pretty obvious. Okay. The next machine we'll cover is all kinds of grinders. This is a tool grinder, but all kinds of grinders have one thing in common. There is a very brittle wheel turning at very high speeds, typically 3600 RPM. Now, this wheel, which looks very strong, is actually very brittle. So if I take a piece of a wheel like this, okay, so you can see that one sharp blow at the wheel when it's turning will cause it to shatter and fly. So the first rule of any grinding is you never stand in front of the wheel. If you need to grind something, you stand on this side or you stand on this side, but you never stand straight, okay? Because over your lifetime you will have the chance to see a wheel shatter at least once, and it flies just like a bullet. Okay, so just a few simple notes about using hand tools. There isn't much safety hazard in using hand tools. The biggest hazard is when hammering, and although these are prescription safety glasses, when you hammer or chisel, it's better to have goggles, even if they are safety glasses. Okay. And the first rule you have when you hammer things is never to hit hard steel on hard steel. Now, the face of the hammer is hardened steel, otherwise it'll get destroyed very quickly. So all the tools which are designed to be hammered on have a soft end where the hammer hits and a hard end. And you can tell it if you try to file this end, you find out right away it's soft and this is hardened. The soft end eventually mushrooms from being deformed, and from time to time you have to grind off the mushroom so no part will fall off. Now, the reason why you can't hit hard on hard, because a huge stress develops at the point you are hitting, and a piece of metal can fly off, and the piece of metal can contain most of the energy of the hammer blow. And this energy is enough for this piece of metal to penetrate your body. So you never hammer hard on hard. Now what happens if you have to? Sometimes there is some situation, say you have to indent something with a ball, and you have to hit hard on hard and you have no choice. And if this is the case, you always hit it through a piece of soft material. So if I wanted to deform this into the shape of the ball, and the ball is hard because it's a ball bearing and the hammer is hard, I would always hammer it like this with a piece of soft, because then this will indent and this would not chip. So that's a very important rule. If you don't know if something is hardened or not, there is two easy ways to find out. One easy way is to try to file it a bit, because you can tell right away if you file it a bit if it is soft or hard. Like these things you cannot file at all, of course the file slips on them. If you don't have a file handy, you can quickly see if something is hardened or not by dropping it on a hardened surface, on a known hardened surface, and see how much it bounces. So for example, if I drop this on the surface, it doesn't bounce at all. Now if I drop this piece, which is made of the same steel but it's hardened, it bounces a little bit, not much. But if I drop this ball on the same surface, it bounces almost to the same height. So the fastest way, if you're not sure, you just try to hit the surface with it and feel the bounce. Like this bounces back quite nicely, this doesn't bounce back. A little bit. Yeah, but this is semi-hard. It's not completely soft, otherwise it'll deform too quickly, but it's not nearly as hard as this end. So one way or the other, you have to be aware if what you're dealing with is hardened or not. And if it's hardened, you don't hit it with a hammer. Okay, a lathe is a fairly safe machine, but still there is two unexpected dangers when working with a lathe. The first unexpected danger is if there is any thread and you put your finger inside, when the lathe turns, it will pull your finger in and shear it off. So for example, there is a thread here, and if you are just tempted to clean out the thread, let's say you just cut this thread, you're tempted to clean it out, and you say take a rag, put it on your finger, and do this. When it turns, it will actually pull your finger in, you wouldn't be able to take it out and shear it off. And I can demonstrate it with a piece of wood. So if this is turning, and this is my finger, and if I just touch the thread, that's it. Now, it locked it inside, it threaded on it, I can't get it out again. Okay, so that's a very, very dangerous thing to do, to put your finger or hand inside a thread. It is a bit less dangerous, but also very dangerous, to touch the outside of rotating things with a piece of rag, because the rag can get wrapped around and pull your hand in. For example, if I have an external thread, and while it's turning, I just want to clean it, it's a good chance this will wrap around and pull your hand into the lathe, and I would just let it go. I wouldn't let it happen, but I just let it go. But just to show you, if this, I'll make it slower. So if this is turning and I try to clean it, it can easily wrap around, and once it starts wrapping around, it just pulls your hand into the machine. So I let it go, but if it happens suddenly, you will be pulled into the machine. Okay? Now obviously when you work with a lathe, you don't have to have any loose sleeves which can wrap around. You can't have any earphone wires hanging. You can't have anything hanging off you, long hair or anything hanging off you which can touch a rotating part, will wrap around. And once it wraps around, it's tenacious because you get a capstan effect. It locks. And once it wraps around, you can never let go. You get pulled into the machine. For example, if I wrap this around like this, okay, so if I pull it, if it's wrapped around a bit more, I can't pull it off. It just locks into the machine and I can't pull it. So the machine will pull me in. No matter what I do, I'll get pulled into the machine. So that's the first rule of safety. Never touch anything rotating with any legs or hands or anything which can be pulled into the machine. The second unexpected danger in a lathe is when working with brass. Brass has a very nasty property of pulling the tool into the brass. Now, normally there is a special set of tools which is ground for brass, and these tools have a zero rake angle. So in other words, the cutting edge is touching the brass square, not at a sharp angle, and same for drills. Drills which are used for brass, there is a flat ground at the end of the drill, so the helix angle doesn't make a sharp angle with the surface, but it's ground flat, so the end is ground flat to be square to the surface of the brass in order not to pull in. Now, if you don't do that, the lathe tool can be pulled into the chuck, or the drill can pull out the drilling chuck into the brass. So let me demonstrate that. Okay. Okay, so what happened here, the drill pulled out the chuck from the tailstock, and now instead of the chuck being stationary, it is spinning with this chuck, and if this hole was deeper, it will pull it out all the way and make it fly out. So watch one more time for 1 second, that this chuck was actually got pulled out, and it's now spinning in the tailstock. So if I move back the tailstock, I see that the chuck was actually left stuck in the part, and now if I spin it, it will fly out. Okay, as far as safety on a drill press, it's a fairly safe machine. The only care you have to take is clamping the part. So let's say if I want to drill a hole here, or any shape like this, I can easily clamp it. You usually start the hole with a center drill. Okay, so let's say here. Because the center mark itself is not always enough to guide the drill, especially if it's a large drill. So you start the hole with a center drill and you follow it up with the right size drill. If the drill is very large, say larger than say 10 millimeters, it's best to drill it in 2 steps. First drill half the diameter and then enlarge it to the full diameter. And that's about it. So this part is very simple. Now, the problem starts when the part you have is too awkward to put in the vise. Let's say you have a big sheet or some odd shape you cannot put in the vise, and you have to hold it when you drill into it. For example, if this was an awkward shape and I couldn't put it in the vise, the most important thing is try not to hold it in your hands, because it can always catch the drill and start spinning, and if it has sharp edges, it'll cut your hand. So if you have no choice, if you can't put it in the vise, so the best thing to do is hold it not with regular pliers, but with some kind of a locking plier, like a vise grip, and assuming there is a center mark and everything, drill it not too fast again. So if something happens, it doesn't happen too fast, and then you can drill it like this. Okay. The same demo I gave you about the dangers of drilling brass also exists here. If this was a piece of brass and I drilled through it, as soon as a drill broke through the brass, it will pull it up. So if this piece is not very secure, it can pull out of the vise. Or the chuck can pull out, if it doesn't have a bar which threads into it, can pull out of the drill press. So everything to do with drilling brass on a lathe also applies on a drill press. Another unexpected danger on drilling in a drill press is some people want to protect the surface of what they are drilling, and they put a rag under it. And it turns out this is a very, very dangerous procedure, because when you put a rag under what you're drilling, as soon as a drill breaks through, it's going to touch the rag, and the rag is going to be wrapped on the drill. So if you have a rag and the drill touches it, you see this. And this is the probability of this happening is exactly 100%. Okay? So anytime you put a rag under something, the rag will be trapped in the drill and everything will fly. So never put anything which can wrap around the drill under the material you're drilling. So if you want to protect it, just use a sheet of paper. Because the same thing doesn't happen with paper. If you want to protect something and you put paper, the drill will just go through the paper, but the paper will not wrap around the drill because it doesn't have fibers which can wrap around the drill. So although we talked already about safety with presses before, I want to repeat the warning, because a press is a very deceptive machine. It looks very safe because everything moves slow, but it creates huge forces and huge stored energy and very high dangers if you don't know what you're doing. So for example, if I have a piece of hardened steel like this, this is about the same weight as, say, in a crossbow, the amount of steel in the bow. Now everybody knows that if you shoot an arrow from a crossbow made of this steel, it can kill you. But that steel in the crossbow can store no more energy than this piece of steel can store when it's compressed, up to the limit of fracture. So actually if you compress it, it can store more energy than if you made a crossbow out of it, because in a crossbow the middle is at a neutral plane. It doesn't carry energy, it doesn't store energy. So not all the steel in a crossbow stores energy equally, while if you compress it, the whole volume stores energy. So if I put this in a 100-ton press and I compress it, and say steel typically would stand 10 tons per square centimeter, so if this is 10 square centimeters, compress in a 100-ton press, I can shatter it. So the moment it shatters, the energy will be released. Usually it fractures along some diagonals, and the pieces fly out just like bullets from a handgun. By the way, with a comparable energy of bullets from a small handgun. Because of that, if you cannot press hard materials. Now, if you have to press hard materials against each other for some reason, you can never even come close to the limit of the strength of the material, and you always should have a bulletproof guard like this half-inch Lexan to stop any fragments. Because if you press a hardened or brittle material here beyond its maximum compressive strength, it's guaranteed to shatter. So it's 100% probability it will shatter and pieces will fly out at you. Now, so be aware before you bend something that it's actually material which is bendable. So it's not hardened steel, it's not 7000 series aluminum, it is not spring tempered beryllium copper, it's not none of the materials which will break instead of bending. Okay? It suddenly jumps up very rapidly. Now imagine if you had a big sheet of this aluminum and you're holding it, it will jump up and fly in your face. And as you can see, it didn't actually bend, the piece just shattered in two. And this piece just shattered.